Hello all, welcome. My name is Kastro Kiran. In the previous video, we have seen how to create a three-tier architecture by using the different services that are available in the AWS cloud. As a part of this video, we are going to see how to automate the creation of EKS cluster. In order to do the creation of EKS cluster, I'll be using the AWS cloud where I am going to create the resources such as the EC2 instances and the VPC network here. And then I am going to use Jenkins in order to create the CI/CD pipeline in order to do the automation of the EKS cluster. And here we are not going to create the EKS cluster just by using Jenkins. Here we are going to use Terraform in order to do the automation. I'll be showing you how to integrate Terraform with the Jenkins pipeline. And once when we trigger the Jenkins pipeline, we need to have an EKS cluster that gets created automatically by using the Terraform scripts, which we are going to write in some time. Let me explain the workflow of the project that I am currently going to show you. Firstly, we are going to launch one EC2 instance and then we will connect to that instance. After connecting to the instance, we are going to install couple of things in the EC2 instance. The things that we are going to install are, the first one is Jenkins and Java. In order to install Jenkins, we need to have the Java. So that's why Jenkins and Java are going to be installed. And once that installation is done, we are going to install Terraform, where we are going to use some of the Terraform commands to plan, execute, and initiate the Terraform. Upon which we are going to create the EKS cluster. And here, in order to install or in order to create the EKS cluster, we need to install Kubernetes inside our EC2 instance. So Kubernetes installation will also be done here. Along with that, in order to create the EKS cluster, we need to have an IAM role. So for that, I am going to use IAM service in order to create the IAM role. Along with that, we will be installing AWS CLI in order to work with the commands. So these are the things that I'm going to use on a large scale. But along with these, I'm also going to show you how to write the Terraform files. In this video, I'm going to use three different types of Terraform files. I'll be writing those Terraform files individually so that you will also have an experience of how to write the Terraform files. Once we write these Terraform files, we are going to create the Jenkins pipeline where I am going to integrate the Terraform files in the Jenkins pipeline. So once we write the Terraform files, what we do is we are going to keep those Terraform files in the GitHub repository. And that GitHub repository, I am going to integrate with the Jenkins pipeline. And whenever we trigger the pipeline, automatically the EKS cluster should get created. And then we are going to see whether EKS cluster has got created or not. So these are the different steps that we are going to follow in this particular video. So let us go to the AWS console and let us work with creation of an EC2 instance, and then we will do the installations according to the requirements. So whatever the resources that I am going to create, all those resources I am going to create in the North Virginia region. You can create in any region. There is no restriction that you should only create in North Virginia region. But as a part of this video, I am going to use North Virginia region to create the resources. So currently I am in the AWS console. So let us launch one EC2 instance by clicking on launch instances here. So here I am going to name the instance as demo EKS cluster. That's the name of the instance that I'm going to give. You can keep any name to your instance. There is no rule that you should give only this name. And here I'm going to use Ubuntu instance. So Ubuntu 22.04, that's the instance that I'm going to use. This is the latest one which is having free tier eligible tag, but I'm going to use 22.04 because it is always recommended to not go with the latest version, just go with the N-1 latest version. So I'm going with the second latest version, which is Ubuntu Server 22.04. So that's the AMI that I have selected. And here, if you want to create the EKS cluster, we are going to install multiple things. So for that reason, the T2.micro instance is not suitable. So for that way, we are going to use the instance type as T2.medium. That's the instance type that I am going to use. And remember, when you're working with T2.medium, you will be charged. But here the charges will be very minimal because we'll just create the cluster, and once after everything is done, we will delete the cluster so that we can minimize the cost also. And coming to the key pair, if you want, you can create a new key pair. If you already have any existing key pairs in this region, you can click on this drop down and you can select the existing key pair. So currently I'm going with one existing key pair which is already available. Otherwise, you can click on create new key pair and you can select the PEM file there. So let me show you that also. Just give the key pair name and make sure to select the key pair file format as a .pem because I'm going to use MobiXterm in order to connect to the instance. So since we are using MobiXterm to connect to the instance, I'm going to use .pem file, right? So let me click on cancel because I have already selected the key pair. And network settings, I'm not going to change any of the network settings. Let it be the default network settings. And here the storage capacity, we can increase up to 30 GB. So I'm going to keep the storage capacity as 28 GB. And here the next thing that we need to do is we need to launch the instance. So let me click on launch instance so that the instance is getting launched here. Once the instance is launched, we are going to use the MobiXterm tool in order to connect to that EC2 instance. So in order to connect to the EC2 instance, we have to use the public IP address of the instance. Once we get the public IP address of the instance, and by using the key pair, whichever is used to launch the EC2 instance, by using that key pair, we will connect it to that instance. So currently this is my instance. You can see demo EKS cluster and you get the public IP address, copy the public IP address, go to the MobiXterm terminal, session, SSH, paste the public IP address in the place of remote host, and by default, all the Ubuntu instances will have the username as Ubuntu, and click on advanced SSH settings, use private key, and then select the PEM file, whatever you have used in order to connect to that instance. So let me select the PEM file. So this is the PEM file. So click on OK. So with this, you will be successfully connected to this EC2 instance. So you can see I have connected to the EC2 instance. Now, once after connecting to the instance, what we will do is we are going to install Java and Jenkins for that. Now, in order to do that, I have already given all the commands in the description of this video. There is a GitHub repository link. In that GitHub repository, I have provided all these commands in order to install Java and Jenkins, in order to install Terraform, and in order to install the Kubernetes and also the AWS CLI as well. You just have to execute these commands. And here what I'll do is instead of executing all these commands one by one, I will be creating a shell file. Inside the shell file, I'm going to paste these commands so that when I execute the shell file, automatically the entire commands will get executed. So I'm just creating a shell file vi jenkins.sh because we are installing Jenkins, right? So I just kept Jenkins as the file name and .sh is the file type. So let me go to the file, press I in your keyboard to go to the insert mode and copy all these commands so that Jenkins installation along with Java will get installed. So currently I am going to use Java and Jenkins here. And especially with respect to Java, I am going to use Java 17 version here. So let me press escape :WQ to come out of that file. Now, if you do ls, you can see this file is currently not an executable file. So let us give the permissions for the file in order to get executed. So to give the permissions, the command is sudo chmod +x, x represents executable, and give the file name. Now press enter. If you do ls, you can see now the file can be executed. So in order to execute any shell file, the command is / give the file name. Okay, / give the file name. So that whatever commands that you have kept inside the jenkins.sh file, all those commands will get installed automatically. Now let these get installed. Meanwhile, we know that Jenkins is going to run on port number 8080. So for the instance, we need to open port number 8080. So in order to open port number 8080, select the instance, go to security. In the security, if you scroll down here, you can see security groups. So click on this security group link. And here is where we are going to edit the inbound rules, where we click on add rule. type is custom TCP, protocol is TCP, and the port is 8080 because Jenkins will run on default port number. So make sure to open this port number so that you will be able to access the Jenkins. Right. Now we have opened port number 8080 for the instance. Right. Let's see whether Jenkins installation is done or not. You can see Jenkins installation is done. You can see Jenkins is currently active and running. Now to come out of this, just press Ctrl C in your keyboard. Hold Ctrl and then type C so that you will come out of it. Now let us go and access Jenkins here. So in order to access Jenkins, copy the public IP address of the instance where you have installed Jenkins, and then go to a new tab, paste the public IP address, give :8080 because Jenkins is running on 8080 port number. So once you give this one, we need to get the password, administrator password, in order to set up the Jenkins. So copy this path. This is where the administrator password will be available. So I'm just going to execute sudo cat. Cat command is used to see the content inside the file. So whatever command that you have copied from the Jenkins console, paste that command and then press enter so that you will be able to see the password. So this is the administrator password. So copy this administrator password, go to Jenkins dashboard, paste it, and then click on continue. Now Jenkins will ask you to install the suggested plugins. So click on install suggested plugins so that whatever the default plugins that are available, all those default plugins will get installed. Once the plugins gets installed, then we have to do the setup, the Jenkins dashboard setup. So for that, it will ask us to provide the username, password, and all those things. So let me provide the username. Let me provide the password also. Let me also confirm the password as well. And let me give the full name as well. And give finally the email address also. Right. Once you give all these details, remember, whenever you want to log into the Jenkins, this is your username and this is your password. So whatever you have kept the password, that should be your password. So click on save and continue. Right. With this, you are good to go and use the Jenkins. Now, we'll come back to this Jenkins console in some time. Meanwhile, let us install a couple of other things. So the next thing that we are going to install is the Terraform. So you can see the Terraform commands also I have provided. So for this also, what I'll do is I'll copy all these commands and I'll create a new shell file here. So let me clear the screen. So I'll keep the file name as terraform.sh. That's the file name. Terraform is the file name. VI is used to open the file and .sh is the file type. So press enter, go to insert mode, and whatever commands I have given here in order to install Terraform, copy all those commands and then go to the mobile XM, place the commands. Okay, paste the commands. Now come out of it, press escape, WQ to come out of it. Now again, if you see here, the terraform.sh file currently doesn't have the executable permissions. So let us give the executable permissions for the terraform.sh file. So sudo chmod +x, the file name. So press enter. Now if you see, the file is having executable permission. Once this is done, let us execute the terraform.sh file, /file name. So the file name is terraform.sh. So with this, we are going to successfully install the Terraform as well. Once after the Terraform is installed successfully, the next thing that we have to do is we need to install the Kubernetes also. Okay, we need to install Kubernetes also. So I'm just going to create one more Kubernetes file, vi k8s.sh. K8s is the file name. You can give any file name. Since in this file, I'm going to keep all the Kubernetes related commands. So I'm just keeping the file name as k8s.sh. Press enter, go to the insert mode, and I have given all the commands to install the Kubernetes. Okay, to install the Kubernetes. So let me copy all these commands and let me paste it here so that Kubernetes installation will also be done. Press escape, :WQ. Now again, if you do ls, you can see k8s.sh file is not having the executable permission. So let us give the executable permissions, sudo chmod +x k8s.s, .sh. Right, sorry, .sh. So let me execute the command one more time. Right. Now if you do ls, you can see k8s.sh file is having executable permission. So let us execute the k8s.sh file, press enter, so that whatever the things that are required in order to work with Kubernetes, those things are also done. You can see kubectl is also done. Now, once this is done, then the next thing that we have to install is AWS CLI, because we have to interact with the CLI, right? So for that reason, we have to install the CLI in our EC2 instance also. So I'll keep one more file, which is called as cli.sh. Okay, cli.sh. So press enter, go to the insert mode. So I have given the commands to install the CLI also, copy these commands and paste it. Remember, all these commands I have already provided in the GitHub repository. So you can find the GitHub link at the description of this video. So press escape :WQ to come out of the file. Now again, if you do ls, you can see the CLI.sh file doesn't have the executable permissions. So let us give the permission for CLI.sh by using sudo chmod CLI.sh. Okay, CLI.sh. Now, if you do ls, you can see CLI.sh file is having executable permissions. So let us execute it ./CLI.sh. That's the file name. Press enter so that the CLI will get installed. Okay, so that CLI will get installed. So this is the first step. Okay, creating the EC2 instance and installing all the required things is our first step. So let me write that step also. So there are different steps that will be there in this session. So I'll just go with step-by-step process so that it will be easy for you. So launching an EC2 instance and installing and installation of required tools. Okay, required tools. That's our first step, right? And then let us talk about the second step that we are working with. Secondly, what we will do is we need to work with creation of AMI user. Okay, creation of IAM user, not AMI, creation of IAM user. Now, why do we have to create the IAM user? Because whenever you want to interact with the CLI, we need the access keys and the secret keys. So in order to create the access keys and secret keys, we have to have an IAM user. So the next thing is creation of IAM user and generation of secret keys. Generation of secret keys. So let us do that. So for that, let us go to the IAM console. So you can go to the AWS cloud and open IAM, where we are going to create an IAM user. Okay, first we have to create the IAM user. After that, we will generate the access keys and secret keys. So let me close this one and then let's generate, go to users here. You can see in the left pane, click on users, click on create user. Currently, I don't have any users. So let me click on create user. And here the user name, I'll just give it as EKS-Castro. Any name you can use. So I'm just going with EKS-Castro. And let us not provide the AWS console access. If you want, you can provide, but again, that's completely up to you. So if you want, since we are creating an IAM user, right? So select create, I want to create IAM user. Password. If you want, you can ask AWS to generate a password. Otherwise, you can itself create one password for your requirement. That's again up to you, right? So users must not create a new password. So let me uncheck this one. Let me click on next. Now here, what we need to do is we need to attach the policies. So let me select the attach policies directly. And which policy we are giving is administrator access. You can see the administrator access policy is available. So just to select this policy so that whatever IAM user that we are creating, it is also going to have an administrator password. So however, we are not going to log in as an IAM user. We'll be doing all the works with respect to the root user only, but we want to create the secret keys and access keys. So I'm just going with administrator access. So let me scroll down and then click on next. So just verify the details. So I have given the username and I have my own password, and then click on create user. So once the user is created, you can see the user has got created. Once the user is created, just go to usage. Okay, just go to usage. And if you scroll down, you can open the user which you have created. And here you can see security credentials. So click on security credentials. And this is where we are going to generate the access keys, that is secret access keys. Okay, secret access keys. So let me click on create access key. Okay, create access keys. And I want to give CLI permission, right? So go with the CLI and then scroll down, acknowledge it. and then click on next, and description tag. If you want to give any tags, you can give it. Otherwise, just click on create access key. So with this, you have got the access key and you have got the secret access key. We'll use this secret access key and access key in some time when we are configuring in the Jenkins. Okay, when we are configuring in the Jenkins. So these two we have to configure in the Jenkins, then only it will work. Right, we'll see that after some time. Now what we will do is, let us go to the Jenkins dashboard. Okay, let us go to the Jenkins dashboard. And here what we will do is, firstly, we will install the plugins. That's our step 3. Okay, step 3 is installation of plugins or configuring Jenkins ILK. That's the next stage that we are going to work with, configuring Jenkins. Now, what we configure with Jenkins, we have to install one plugin, pipeline stage view. If you want to see whether pipeline is getting executed stage by stage, and if you want to know more details about the execution process, it is always recommended, just go to the manage Jenkins, and here you can see an option called plugins. So click on plugins, and here go to available plugins, just go with a plugin called pipeline stage view. So this plugin will give us stage by stage execution of the pipeline. So let me select this pipeline, go to click on install, scroll down, and once the installation is done, just click on go back to the top page. So click on go back to the top page. So that's the first thing. So I have installed pipeline stage view plugin. Once this is done, next we have created the access keys and secret keys, right? These two keys we have to make sure that they are available in the Jenkins. So we have to configure the access keys and secret keys in Jenkins for AWS CLI. So just go to Jenkins dashboard, go to manage Jenkins. In the manage Jenkins, if you see under security, there is an option called credentials. So click on credentials, and here you can see global credentials. So click on global. Now here is where we have to add the credentials. So let me click on add credentials here. Okay. Now here we have to select the kind. So currently we have the secret keys, right? So these are secret keys. These secret keys. So the kind will be secret text. Okay, the kind will be secret text. So select the secret text, and the scope is global. Okay, scope is global. And here we have to give the secret. So what is the secret? So first we will give the access key. So we have access key and secret access key. Two are there. So first we will configure access key, and then we will configure secret access key. So let me copy the access key. Okay, let me copy the access key, go here, and then paste the access key here. Okay, paste the access key here. Now, right, the next thing that we have to do is ID. So what is this? This is an access key. So I'll just give it as AWS underscore. So let me give it as AWS underscore secret key or access key. It's an access key, right? So I'll just give it as a access underscore key. Remember, these names are very, very important when we are working with the creation of Jenkins pipeline. So I'll get back to you there also in some time. But just remember, I have created the AWS access key. Okay, I have configured the credential of AWS access key with the name as AWS underscore access underscore key. That's my ID. Okay, so let me click on create. Let me click on create so that AWS access key got created. Now we have one more thing, which is a secret key. Okay, secret access key. So let us configure one more credential for secret access key. So click on add credentials. Kind, again, here also it's a secret text. So select it as a secret text, and the scope is global secret. So what is the secret here? Our secret is a secret access key. So copy the secret access key, go to Jenkins dashboard, paste it, and here we need to give ID. Okay, ID. So ID is a AWS underscore. It's a secret key, right? So I'll give it as a secret underscore key. Okay, AWS underscore secret underscore key. The same description I'm going to give it here also. Right, now let's click on create. Now we have successfully configured AWS access key and AWS secret key. Remember, these names I'm going to use it when I'm creating the Jenkins pipeline. So just have an idea about this one. We'll use it in some time. Right. Once this is done, the next thing that we have to do is we need to write the Terraform files. Okay, we need to write the Terraform files. So that's our fourth step. So step 4 is writing Terraform files. So let me write the Terraform files instead of having an already written Terraform files. I'm going to show you how to write the Terraform files and what are the different Terraform files that I'm going to use. That also I'm going to show. So writing Terraform files, .tf files you can say. Okay, .tf will be the extension of the file. Now, in order to write the Terraform file, first let me go to the VS Code editor. Okay, currently I am there in the VS Code editor. So I hope you all have a VS Code editor. So if you don't have, at least try to install the VS Code editor. So here, what I have done is I have created one folder called with the name called Terraform. Okay, I have created one folder with a name called Terraform. Now let us create some files here. So here we are going to create 3 files. Okay, when we are writing Terraform script, we are going to create 3 files. The first file is known as a provider file. Okay, provider block. We can also call it as provider block. So let me go here. You can see a new file icon. Click on new file and give the file name. So the file name I'm going to give it as provider.tf. That's the file name. Provider.tf. All Terraform files will have an extension called .tf. So let me press enter. Now currently you are there in the provider.tf file. Now here what we need to do is we need to write the provider block. Okay, we need to write the provider block. So what is our provider block? Our provider block is exactly the AWS. So we are using AWS cloud, right, to work with all these things. So that's why we have to mention that. Okay, we have to mention that. So let us do that one. So let us write the terraform.provider.tf file. So firstly, what I'll do is I will configure some locals here. Okay, I'll configure some locals here. So let me open the flower brackets. So locals I'm going to configure because I'm going to use a couple of local things. So first I'll go with the region. So whatever resources I'm going to create, I'll be creating in North Virginia region. So for North Virginia region, the code is US-East-1. That's the region code. If you want to create the resources in any other region, you just have to give the region code according to your requirement. And then the name I'm going to give. So the name of the EKS cluster that I'm going to give it as Kastro-EKS-cluster. So this is my EKS cluster name. You can give any name here. And then we have to create our cluster in our custom network. Okay, in our custom network. So we have to provide the VPC CIDR range. So let me press enter. So just type VPC underscore CIDR. Okay, VPC underscore CIDR. So here we have to give the VPC CIDR range. So I'm going to use the VPC CIDR range as 10.123.0.0/16 I'll give. Okay, /16 I'll give. This is my VPC CIDR range. Now, once we go with VPC CIDR, we have to mention which availability zones we are going to use. So next thing is we have to specify availability zones. So I'll just give it as AZS, which represents availability zones. Now I'm going to use 2 availability zones. If you want to use, you can use multiple availability zones. So let me use 2 availability zones. So the first availability zone is US-East-1A. That's one availability zone in the North Virginia region. And the second availability zone is US-East-1B. This is my second availability zone. So in these 2 availability zones, I am going to create the resources. Right. So firstly, I have given the region name. Then I have given the cluster name. Then I have given the VPC CIDR range. Then I am telling in which availability zones the resources has to get created. Now, for every VPC, we have the public subnets and private subnets. So let me give the CIDRs of public subnets first. So public underscore subnets. Okay, public underscore subnets. So let me open the CIDR for public subnets also. So the first subnet range, I'll be giving it as 10.123.1.0/24. This is one CIDR range that I am going to use. And the second CIDR range for the same public subnet, which I am going to use is 10.123.2.0/24. This is my second CIDR range for public subnet. So similarly, we need to create a private subnets also, right? So let us give it as private subnets. Okay, private subnets. So for private subnets also, we have to provide the CIDR blocks. Okay, we have to provide the CIDR blocks. So let me give it. So the first CIDR range is 10.123.123.3.0. Okay, I'll use 3.0. So 10.123.3.0 slash, I'll give it as 24 as the CADR range. Okay, so CADR range. And then the next CADR block for private subnet. Okay, the next CADR range for private subnet, I'll be giving it as 10.123.4.0 slash 24. This is the second CADR range which I am going to use. So here, let me give underscore here, private underscore subnet, right? So I have given the public subnets and private subnets. I will also use one more thing, which is called as intra subnets. Okay, which is called as intra subnets. I'll explain you what is this intra subnets, but let me just create for some now. So I'll just give it as intra subnets. And for this also, I am going to open the CADR range, which is 10.123.5.0 slash 24. This is one CADR range. And the second CADR range, which I'm going to use is 10.123.6.0. Okay, 6.0 slash 24. So these are the different CADRs that I'm going to use for public subnets and private subnets. So two public subnets I'm going to use, two private subnets I'm going to use, and two intra subnets I'm going to use. Right. Now, if you want to give any tags, you can also give the tags also. So let me give tags equals to, open the braces, and let's give it as, I'll give it as an example here. You can give any tag here. So I'll just give it as local dot name. So I'm providing the locals here, local dot name. So all these are locals. Okay, all these are locals. Right. This is done. Now, where we are creating all these resources, we are creating all these resources in the AWS cloud. So for that, we have to provide the provider block. So I'll just give it as a provider. So what is our provider? AWS cloud. So AWS I'm going to give, and then open the flower brackets, and then region. In which region I'm creating all these things, we have to specify that. So region equals to, what is the region? US-East-1, because I'm going to use North Virginia region. So North Virginia region code is US-East-1. Okay, US-East-1. Right. So this is about, which is called as a provider block. Okay, this is the provider.tf file. So if you want me to explain this entire file again, so let me explain it in a short way. So firstly, I'm going to provide locals block. Okay, I'm going to provide the locals block. So what does locals block do? Locals block defines reusable variables or constants. These are reusable variables. Reusable variables are constants that can be referenced throughout the Terraform configuration. Okay, throughout the Terraform configuration, these locals will be used. So why I'm using this one? Because this helps to make the code cleaner and easier to manage. Okay, this helps to make the code cleaner and easier to manage. So for that, region, what is the region? Locals, first thing I have provided, region. So here I have provided the AWS region where I want to create the resources, which is North Virginia region. And then the second one is name. So here I am going to give my custom name for the EKS cluster, which is Kastro-EKS-cluster. The next thing is CADR for VPC. So the CADR block defining the IP address range for the virtual private cloud, which is our own network. So it allows a large range of IP addresses, /16. Okay. And then the next thing is I'm going to use two availability zones. And by using two availability zones, I'm going to create the public subnets. Okay. CADR range for public subnets. So what does public subnets do? Public subnets allows resources like load balancers to be accessible from the internet. So we can use any resources here in the public subnets. And then private subnets are not directly accessible from the internet and are often used for backend resources like application servers or databases. If you want to configure, you can configure using private subnets. And the next one is intra subnets. So the intra subnets are something which can be used only for internal communication. That is, let's say between AWS microservices, if I want communication, then I can use intra subnets. Between the worker nodes, if I want to use the communication, I'll establish the communication between intra subnets. So these subnets are also two. One is this one and the other one is this one. Right. And then I have provided the tags. So what is tag usually defines? It is a map defining tags in order to assign to the resources created in this configuration. Okay, created in this configuration. So here the example tag is set to a value called local.name. Local.name. So what is the name here? What is the name here? This is the name. Castro-EKS-cluster. Okay, Castro-EKS-cluster. And this is the last one, which is the provider block. So this block specifies the cloud provider. This block specifies the cloud provider. You can see that, right? So which cloud provider we are using? AWS cloud provider. Okay, AWS cloud provider, right? And here I'm going to use the region. So this defines the AWS region where the resources will be deployed. So here I'm going to use the region as US-East-1 because I'm going to use the North Virginia region. So this is about the provider.tf file. In the provider.tf file, I have given two blocks. One is called as local block and the other one is provider block. Right, this is done. So just save the file. So I have saved the file. So now the next thing that we have to do is we have to create our own VPC, right? Okay, we have to create our own VPC. So let us create another file which is called as vpc.tf file. Okay, vpc.tf file. So let us create that. So here you can see the file icon. So click on a new file, click on new file, give the file name. Whatever name you want, you can provide, but I am just going with vpc.tf file, vpc.tf. That's the file name which I am giving. Again, you can give whatever name you want, right? Now here, what we will do is we are going to configure. Okay, we are going to configure all the subnets, private subnet, Kubernetes roles, multiple things we will also do. Okay, multiple things we'll configure here. Right. So here, firstly, what we need to do, we are using modules, right? VPC module we are using. So VPC, the module name is VPC. Okay, the module name is VPC. And then source. Okay, what is our source? Our source is a Terraform file. Okay, Terraform file. So let me give it as a source equals to, let me give it as equals to first. Right, source equals to Terraform, Terraform, Terraform hyphen AWS hyphen modules. So we are going to use the Terraform AWS modules here. What is our source? This is our source. Okay, you can also refer official documentation of VPC also in the for Terraform. So VPC, I'm going to use VPC as the module, right? In which cloud service provider? AWS. So I'm just giving it as AWS. And version, I am going to select any version which is greater than or equals to 4. That's a version that I'm going to select. So version equals to, so I'll just give it as version. Okay, I'll just give the version which is approximately equals to or nearly equals to, or greater than or equals to 4.0. That's the version that I'm going to give. 4.0. Right. This is done. So the first module is VPC. Now here, how to get the VPC name? How to get the VPC name? So we have to provide that name equals to local.name. Local.name. If you remember in the provider.tf file, we have provided locals, right? So we have given the name also. We have given the name also. So I am telling from here, from the providers.tf, where I have provided the locals block, from the locals block, you get the value. That is what I am defining here. And then CADR range also. CADR equals to, okay, CADR equals to local. So I have configured in the locals block, right? Local dot, okay, local dot. What is the VPC name I have given? VPC underscore CIDR. Remember, whatever name I have provided here, VPC underscore CIDR, that's the same name that will come out here also. VPC underscore CIDR. Make sure to give the names properly. And then availability zones. Availability zones. So here I have given in the locals block, which is a locals.AZS. Locals.AZS. That is the name that I have provided. Sorry, not locals, local. Local.AZS. So you can see the same thing in the provider, which is AZS. That's the availability zone. Similarly, we have to give private subnets, public subnets, and intra subnets. So let us give that also directly here. So AZS I have given. And then next thing is private subnets. Private underscore subnets. Okay, private underscore subnets equals to local dot. What is the name I have provided? Private underscore subnets. That's the name that I have provided. Similarly, public subnets also. PUB public underscore subnets equals to, in the locals block, I have provided it, right? So local dot public underscore subnets. Public underscore subnets. That's it. And then the next thing, we have also provided the intra subnets. So I'll just give it as one more thing, which is intra underscore subnets. And if you remember, in the locals block, I have given the intra subnet's name also. Intra subnet's name also. So I will tell to get it from the local. So local dot intra underscore subnet. Okay, intra underscore subnets. Right. So these are the things that I have provided. Now we need internet connection, right? So in order to have an internet connection, we need to have an NAT gateway. Okay, we need to have a NAT gateway. Our internet gateway is also fine. So let me enable the NAT gateway. So enable underscore NAT underscore gateway. So I want to enable NAT gateway, right? So enable underscore NAT underscore gateway equals to, I'll give it as true. When I give true, it represents, it is going to enable the NAT gateway. It will create a NAT gateway also. Now, if you want, you can also create tags for public subnets and private subnets also. That's again up to you. So let us give some tags. Okay, public underscore subnets underscore tags. So I'm just giving the tags. These are tags are optional, but it is good to give the tags. So I'll just go with public underscore tags. And then here I'll be using kubernetes.io. Okay, kubernetes.io. This is again, I'm getting it from the AWS official documentation of Terraform, aws.io/role/internal ELB. ELB represents elastic load balancer. Elastic load balancer. So I'll just give it as the value as a 1. I'll give the value as a 1. Okay, internal hyphen ELB. So this can be used for private subnet. So let me go with public subnet. So for public subnets, I'll give it as a just instead of internal. So I'll just give it as a ELB alone because I'm going with public subnets, right? So I'm going with kubernetes.io/role/ELB. That's done. Now, the next thing that we have to do is we have to go with private subnets also. Okay, we have to go with private subnets also. So let me give that also. Private underscore subnets underscore tags. Okay, private underscore subnet underscore tags equals to, let me open the braces. Now here also I'll be giving it as Kubernetes. Okay, kubernetes.io/role/ I'll keep it as internal. Okay, internal load balancer I'm using. So internal ELB equals to 1. I need 1. I need 1. So like this, we are going to write the vpc.tf file. vpc.tf file. So just have an idea about this one. I'll explain once again, just have an idea. So the first one, I'm going to use the module. Okay, I'm going to use the Terraform module, which is a VPC block. Okay, the module name is VPC. Okay, the block is VPC block. So this block defines a VPC resource using a pre-built Terraform module. So this is my pre-built Terraform module. Okay, pre-built Terraform module. So what it does, it simplifies VPC creation by reusing the logic provided in the module. Okay, by using the logic provided in the module. So what are the configurations I have given? I have given a couple of inputs to the VPC module. So the first name is source. Okay, it specifies the location of the module, where it is coming from the Terraform official documentation. Okay, this is the name of the module hosted in the Terraform registry. Remember this. Okay, and the module provides a reusable code to create and manage AWS VPC. And version is something which specifies the version module. So I'm going to ensure the compatibility with the versions in the 4.x series. That is why I have given greater than or equals to 4.0. Right. And the next thing is VPC configuration parameters. Okay, VPC configuration parameters. So two parameters I have given. One is called as name and the other one is CADR. So the name of the VPC passed from where? Passed from locals, where the local is available in the provider.tf file. Similarly, CADR. So the IP address range from the VPC taken from which one? From the locals, where locals I have provided in the provider.tf file. What is the CADR range? 10.123.0.0/16. That is a VPC CADR which I have provided. You can see it here. Right. And the next thing that I'm going to use is subnets, availability zones and subnets. So here, the subnets are assigned based on the locals block again. So the availability zones where the subnets are created, I'm going to get it from the local block again. That is US-East-1A, US-East-1B. Similarly, private subnets with 2 CADR blocks, I'm going to get it from the locals, and private subnets also from the locals, and intra subnets also from the locals. And the other features, I'm going to enable the NAT gateway. Okay, I'm going to set it as true. which indicates that a NAT gateway is enabled. Why do we need NAT gateway? A NAT gateway allows private subnets to access the internet. Okay, NAT gateway allows a private subnet to access the internet. Why do we need internet connection for that? Because in order to download any kind of updates or communicating with external APIs, for all these things, we will need NAT gateway. NAT gateway. So here I'm going to use NAT gateway. I'm going to use NAT gateway, which allows private subnets to access the internet without exposing the resources to the incoming traffic. Remember, we are not getting the incoming traffic. I am not going to allow it for the incoming traffic, right? And then subnet tags also I have provided. Public subnet tags. These are the tags for public subnet, which is kubernetes.io.io/role/elb equals to 1. /elb equals to 1. So what does it mean? It marks the public subnets as eligible for creating elastic load balancer. Okay, public subnets are eligible for creating the elastic load balancer in Kubernetes. Similarly, private subnet tags also. Okay, so this marks the private subnets as eligible for creating the internal load balancer in Kubernetes. Okay, internal load balancer in Kubernetes. So this is about the different things that I have given it in the vpc.tf file. Okay, vpc.tf file, right? So our vpc file, vpc.tf file is also done. Okay, it is also done. Now the next thing that we have to do is the EKS. Okay, we have to automate the EKS, right? So for that, we have to write one more module, which is called as EKS module. Now we'll create one more file, which is eks.tf file. Okay, eks.tf file. So let me create that file. So click on the file icon, new file, and I'll give the file name as eks.tf. So let me press enter. Now here we have to write a EKS module. So the module first I have to provide. What is our module? EKS. So I'll just give it as EKS and then open the flower braces and then source where I'm getting this module. This module again I'm getting from the Terraform official documentation. So Terraform -AWS- modules. We have a module called EKS for AWS Cloud. So I'm giving this. And version, I am going to use the version which is 19.15.1. Okay, if you want, you can also go with any other versions also, but I'll go with 19.15.1 or 15.1. Right. I have used the EKS module. Now, let us get the cluster name. So cluster_name. If you remember in the locals, that is in the provider.tf file, I have provided local name, right? So I'll just give it as a local.name. Local.name. So it will get the cluster name from the locals, that is provider.tf file. Right. And then cluster endpoint. So we have to write that also, cluster endpoint. So do we need to give public access to the cluster endpoint? So we have to specify cluster endpoint public access equals to true. I'll give that. I'll give public access to the cluster endpoint. Right. Once we do this one, next, if you want to add any add-ons for cluster, you can do that also. So I'll just go with a couple of add-ons for the cluster. Cluster add-ons equals to, open the flower braces. Okay, open the braces and then coordinates. So I'll just give it as COREDNS. That is a core DNS. Okay, that is a core DNS. So core DNS equals to, open the flower bracket. So I'll go with the usage of most recent one. Okay, most recent one. That is core DNS. I'm going to use the most recent. So I'll enable it as a true. I'll give it as true. Right. Once this is done, then we need kube proxy also. So let me go with kube proxy also. Kube-proxy. Okay, kube-proxy equals to. So for kube proxy also, I'm going to use the most recent one. So most_recent equals to true. So it will automatically get the most recent one as well. And the next one is a VPC CNI. Okay, VPC underscore or VPC-CNI. So I'll just go with the CNI here. And here also for VPC CNI, I am going to use the most recent one. So most_recent equals to true. I'll set the value as true. Okay, so these are a couple of things which I am going to provide. And the next thing that we need to do is we need to provide the VPC ID and all those things. Okay, we need to get the VPC ID and all those things. So let us write that also, VPC_ID. Okay, VPC underscore ID. So I'll get it from module dot VPC underscore ID. We have provided VPC module, right? So I'll get it from there. Okay, module dot VPC underscore ID. Right, that is done. Now, the next thing is subnet IDs. So we have provided subnet IDs also, right? So subnet IDs equals to, I have provided in the module. What is the module? So module dot VPC dot private underscore subnets. Okay, private underscore subnets. And similarly, we need to get a control plane subnets. Whenever you are creating a EKS cluster, we'll get the control plane. So let me give that also, control underscore plane underscore subnet underscore IDs. Control plane subnet IDs. So let me, here it is plus, it is should be underscore. Yeah. Control subnet IDs, control plane subnet IDs. And this also I'll get it from module, which is VPC dot, okay, module dot VPC dot intra underscore subnets. Intra underscore subnets. Right. So I have provided that also. Okay. Now let us create a EKS managed node group. Let us create a EKS managed node group. So here, in order to create EKS managed node group, we need to get the EKS managed node group. So I'll just give it as EKS underscore managed underscore node underscore group. I'll get the default value. So I'll give it as the defaults. I'll get it as defaults equals to, open the braces. And here I am going to get the AMI type. Okay, I'm going to get the AMI type. So I'll just specify AMI underscore type. So you can type, you can select any AMI type, but here I'll be going with AL2 underscore X84. X86 I'll use. X86 underscore 64. I'll explain you what is this in some time. Okay. And then instance type. For EKS cluster, we cannot go with tt.micro or tt.medium. We need large instances. So I'll just specify the instance type also. So instance underscore types. Instance underscore types equals to, so I'll provide the instance type as M5 dot large. That's the instance type which I need for the EKS cluster setup. Okay, right. Once this is done, then I'm going to attach cluster primary security group. I'm going to attach cluster underscore primary underscore security group underscore group equals to true. I'll set the value to true. Right. This is one thing. And the next thing that we have to do is we need to give EKS managed groups. Okay, EKS managed node groups. So let me specify that also. EKS underscore managed underscore node underscore groups. Okay, managed underscore groups. So let me open the braces again. And here I'll give the cluster name. Let's say I'll give it as a KK-cluster-WG. You can give any name. So I'm just going with the KK-cluster-WG. Right. And then equals to, and then open the braces, and minimum size. I'll provide minimum, maximum, and desired we have to provide. Okay, minimum size equals to 1, maximum size equals to 2. Sorry, maximum size equals to 2, and desired underscore size equals to 1. This is the minimum, maximum, and desired size for EKS managed node groups. And for node groups, we have to specify the instance type again. So instance type, okay, instance underscore types, instance underscore types. So here I'll be using T3.large instance. So T3.large. So I'll just keep it in the quotations since it's a string. So T3.large. Right. I have provided that. Then the next thing, capacity type. So I want to use the spot instances. So I hope you know we have different category of instances, spot instances, reserved instances, those things. So I'll just use spot instances just to save the charges. Okay, just to save the charges. You can use any of the type of instance types. There is no problem. So I'll just go with capacity type as a spot instances just to save the bill. Okay, and then tags I'll be giving. If you want, you can give. Again, these are optional. So I'll just give it as an extra tag. I'll just give it as one extra tag. Let's say hello world. Okay, I'll just go with hello world tag, or any name you can give. So just go with hello world tag. That's more than fine. Okay, that's more than fine. Right. Once this is done, then if you want to provide tags for locals also, you can provide one more tag. So tags, okay, tags equals to local dot tags. Local dot tags. So it is going to get the tags from locals block, where I have provided the locals block in the provider.tfl. So this Terraform configuration block setups an EKS cluster using a Terraform AWS modules / EKS / AWS. This is how we have to write the Terraform scripts. You can see the entire Terraform script. I'm writing it now itself, because if I have to explain, I should have explained directly. But since you need to have an idea about how to write the Terraform script, I'm writing directly here itself in the session itself. Right, let me explain once again from the beginning. So first I have provided the module, which is EKS block. Okay, EKS block I have provided. So this block uses a Terraform module from the Terraform registry. Okay, this is the Terraform module from the Terraform registry, which the registry is Terraform AWS modules / EKS / AWS. So this is to provision an EKS cluster and its associated resources. And here I'm going to give the inputs to the module. So where it is going to get the inputs from the source. What is the source? Source is this one, which is from Terraform registry. Okay, Terraform registry. This is the module in the Terraform registry, remember. And then version, I'm going to use the version which is 19.15.1. Okay, that is the version that I am using. If you want, you can use the latest versions also, there is no issue. And the cluster configuration. So basic settings I'm doing here. Okay, with respect to the cluster configuration, first the basic settings. What are the two basic settings I have given? I have given cluster name and cluster endpoint public access. So cluster name, it is going to get from the locals block, which is available in the provider.tf file. Okay, so what is the name I have given the local name? If you go here, you can see the name I have given it as a Kastro EKS cluster, right? And then cluster endpoint public access. So what does it will do? It will enable public access to the cluster endpoint. Okay, it will enable public access to the cluster endpoint, allowing external access. So it will allow the external access via kubectl. Okay, via kubectl to the Kubernetes API. Okay, this particular thing will enable public access to the cluster endpoint, allowing external access via kubectl to the Kubernetes API. These are the basic settings which I have done. And then I have given cluster add-ons also. Okay, cluster add-ons. 3 add-ons I have provided. The first one is a core DNS. So it is going to add core DNS, which is the default service discovery mechanism in Kubernetes. Okay, core DNS is the default service discovery mechanism in Kubernetes. And then I have provided the kubeproxy, which is going to manage the networking and Kubernetes API communications within the cluster. Okay, it manages networking and Kubernetes API communication within the cluster. That is what kubeproxy will do. And VPC CNI. What does CNI represents? Container Network Interface. So it configures AWS VPC CNI plugin for the efficient pod networking in AWS. For the efficient pod networking in AWS. And here, if you see most underscore recent equals to true. For all the 2 add-ons, for all the 3 add-ons, I have provided that. So this true enables the recent or most recent compatible version of each add-on that is used. That's why I have provided true as the value. And the next thing that I have provided is networking. So these parameters talks about the networking in the cluster. Okay, in the cluster. Now, first thing is I'm going to get the VPC ID with the ID of VPC in which cluster is deployed. Okay, and what it will do, it will retrieve the value from the module. It will retrieve the value from the module. Similarly, subnet IDs, that means the private subnets for the worker nodes, which will be retrieved using a module.vpc.private_subnet. Okay, remember this, right? And the next one is a control plane subnets. Control plane subnets for the EKS cluster plane assigned from module.vpc.intra_subnets. That's again one more thing. Okay, that's again one more thing, right? And the next thing is managed node groups, EKS managed node groups. So EKS provides managed node groups for simplified worker node provisioning and management. Okay, EKS provides managed node groups for simplified worker node group provisioning and its management. So here I have set the default values. So defaults for managed node groups are a couple of things. One is AMI type, which actually specifies the AMI. What is an AMI? Amazon Machine Image. For which one it is going to specify? For the nodes. For the nodes. So here AL2 underscore x86 underscore 64 is used, which is indicating Amazon Linux 2 AMI. Okay, it indicates Amazon Linux 2. AL represents Amazon Linux, 2 represents Amazon Linux 2. And instance type. So I'm going to use the instance type for worker nodes as m5.large. m5.large. And then I'm going to attach cluster primary security group. So it is going to attach the primary cluster security group to the nodes for secure communication. That is why I have given it as true. And the next thing is I am going with node groups. So this block defines a specific node group which is named as kk-cluster-wg. Okay, this is the node group name. Remember this node group name. And then here I am going to give the scaling configuration, that is minimum number of nodes, maximum number of nodes, and desired number of nodes to maintain. Right. And then once the cluster is created, how many nodes will get created? Based on the desired size, whatever you have given, the number of nodes will get created. And then the instance configuration I have provided, it actually specifies the instance type for the nodes. Okay, we are creating nodes, right? It is going to specify the instance type for nodes, which is a T3.large, which is a cost efficient general purpose instance type. And here I have given the capacity type as a spot, where it uses AWS spot instances, which are cheaper but less reliable. So since we are practicing, so let us go with cheaper but less reliable ones only. That's not an option. That's not a problem. And here I have added additional tags to the metadata of the node group. For the node group, these tags will be attached. So it includes a custom tag, which is called as hello world tag. You can add any tags to that. And finally, I have added one more tag. This tag applies to all resources created by this module. Okay, whatever tags that we are going to create, it applies to all the resources created in this module. So which is sourced from local.tags. So where we have local.tags, it is there in the provider.tf file. Okay, provider.tf file. You can see tags in the provider.tf. So this is how we can write these Terraform files. So 3 Terraform files we have written. One is called as provider.tf file, and the second one, which is vpc.tf file, that is for custom network. And third one is EKS.tf file, which is to set up the EKS cluster and its required configurations. So this is what we have done so far. Now, what we have to do is we have to create Jenkins pipeline. Okay, I'll integrate all these things with the Jenkins pipeline. And then once I trigger the pipeline, automatically these things should get executed whenever pipeline gets triggered. Okay, whenever pipeline gets triggered. So let me write that step. So step 4 is writing Terraform files, which is done. Next, step 5. So what is step 5? Creation of Jenkins pipeline for automating EKS cluster creation using Terraform. So we'll do that also. Okay, we have to do that as well. Right. Now here, what we need to do, first we'll go and create the pipeline. But before creating the pipeline, what you have to do, make sure you are going to keep this entire code, all these Terraform files in the GitHub repository. You will have your own GitHub repository, right? So make sure to send all these codes, to push all these files to the GitHub repository. In my case, I have already created one GitHub repository, and the files also I have kept already some time back. But I have paused the video before I have kept the files in the GitHub repository. I'll show you that GitHub repository also. So whenever you want, you can fork that repository directly. Let me show you that repository also. So you can see this is the repository where I have kept all the Terraform files. So if you go to this Terraform folder, you can see EKS.tf file, provider.tf file, and vpc.tf file. So all these files I have already uploaded. Now, here what we will do is we will integrate this particular GitHub repository. And when you are working, if you want to get the Terraform files and other documentation for executing commands and all, So you can just fork this repository. You can see an option called fork, and you can also start this repository, because whenever I do any changes, you will automatically get the updates into your forked repository. And I would also recommend you to to start this repository as well. Okay, so you can fork the repository when you want practicing, or when you can directly integrate your own GitHub repository as well. Right. So I have just given this one. Now what I will do is I'll integrate this particular thing with the Jenkins pipeline, right? So first, let me go to the Jenkins, go to Jenkins dashboard, and here is where we are going to create the pipeline. So let me log in once again. So just give me a second. I'll just log into the Jenkins. Once we log into the Jenkins, then we have to create the pipeline. Okay, we have to create the pipeline. So click on new item, and then click on job name. Let's say I'll give the job name as a Jenkins plus EKS plus Terraform job. I'll just give it in this way. And we need to create pipeline job. So select pipeline, click on OK. Okay. Now here, what we have to do is we have to write the pipeline. So let me go to pipeline here, and let me get the pipeline script from SCM. So currently I haven't kept any code, any Jenkins file in the SCM. So we have to write on our own. So let me write the pipeline script for a sample case. Okay, by using the sample thing. So right. So first, what I'll do is I'll explain you the Jenkins pipeline. Okay, I'll explain you the Jenkins pipeline by writing it individually. So let me go with hello world pipeline, a simple hello world pipeline. Now let's write the pipeline. So pipeline agent any. Here we are setting an environment, right? So what is our environment? Our environment is AWS access keys and secret keys. And we have to specify the region also. So I'll just give it as environment block. Okay, environment, open the braces. Okay, open the braces. And then we have to provide AWS access key ID. We have specified that, right? So AWS underscore access underscore key underscore ID equals to, if you remember, in the credentials I have configured. So what is the name I have configured with? I have configured with AWS. Let me write that. AWS underscore access underscore key. If you remember, some time back, we have configured the credentials. So the same names you have to provide it here. Remember that. Same names you have to provide it here. And similarly, we have to provide the secret key also. So AWS underscore secret underscore access underscore key. Access underscore key, where here also I'm going to provide the credentials. So the credentials are, which I have configured it as a AWS secret key. That's the name that I have provided. So AWS secret underscore key. AWS secret underscore key. So here also let me give the space here. I haven't given. Yeah, that's it. And then in which region I want to create the resources? I have to specify the default region, right? So AWS underscore default underscore region. So the region is US-East-1, because I want to create all the resources in the US-East-1 region only. So that's why environment I'm providing. Okay, I'm providing the environment. Right. Now let us write the stage. First stage, clone the code. That is the stage name I'm giving. Clone the code. From where it will clone? From the GitHub repository. It is going to clone the code. Now here, steps. So here we have to generate a pipeline syntax for that. So go to pipeline syntax. I'll open it in a new tab. Go to pipeline syntax. In the pipeline syntax, we have an option, okay, under sample step. Okay, we have an option under sample step. So let me select that sample step, which is checkout from version control. You can see this. Checkout from version control. So select this. And here, select the SCM. Where is our code? In the GitHub repository. So select Git, provide the repository URL. So I'll just copy this one. When you fork it, you can provide your own repository URL. So I'll just go with code, go to copy the repository URL. And currently the code is in which branch? Main branch. So we have to specify that also. So let me provide the repository URL. And once that is done, since it's a public repository, you don't have to go with any kind of credentials. So let it go as it is. And branch, where is my branch? I mean, in which branch the code is available? In the main branch. If you see, I have only one branch, which is main branch. So the entire Terraform files are available in the main branch only. So I'll just give the branch name as main, and then click on generate pipeline script. So I have generated it. So copy this entire one. Okay, copy this entire one, go to Jenkins pipeline, and here in the place, remove this echo. Echo is not required now. Okay, paste it, paste it. That's it. So that's how you can do it. So I'll show you once again. Make sure to remove everything properly and then paste it everything again. Right, I have done that. This is my first stage. This is my first stage. So what does it do in the first stage? It is going to clone the code from repository. It is going to clone the code from a repository. That's done. Right. Now the next thing is we have to write one more stage, which is initializing the Terraform. We have to initialize Terraform, right? So let us initialize the Terraform. Let us initialize the Terraform. So let me click enter. Sorry, let me click enter here. Right, let me click enter. I'll just copy this entire thing. Whatever is there here, I'll just copy this entire thing. Okay, I'll just copy this entire thing. And let me write that stage. What is my second stage? Terraform initialization. Okay, I'll just give the stage name as Terraform. Terraform initialization. Initialization. Right. So I have to initialize Terraform. So for that, I have to write the command. So how will you initialize Terraform? We have a command called Terraform init. So first, what I have to do, I have to tell to go into the directory called Terraform. Terraform. So let me give the directory name, which is Terraform. Terraform. Right. So if you remember in the GitHub repository, sorry, not here, just me, I'll just remove this one. Right. Steps should be as it is. And here I have to write the script. I have to write the script. Let me delete this entire thing. It's not required now. Let me select everything and delete this all thing. Right. So here what we will do is we have to write the script. So under steps, let me give it as a script. Let me give it as a script. I have given that. And then directory. If you remember in the GitHub repository, I have one folder with the name called Terraform. Okay, inside this folder, it has to initialize Terraform. So I'll give this name. Whatever is the name here, you should give same name here also. Remember that. So directory is a Terraform. Directory is Terraform. So Terraform. Same name you have to give, but make sure of that. Don't forget it. And then give square brackets, open it. Now what we have to do, we have to initialize shell command. What is the shell command to initialize Terraform? Terraform init. Terraform init. Right, I'm good with that. I'm good with that. Now we have to write the next stage. So I'll just copy this entire thing, leaving the last two flower brackets. Okay, and then press enter. Let me write another stage. Now, once Terraform is initialized, we have to validate it, right? We have to validate. So Terraform validation, I'll keep. Terraform validation, that's the stage name. Terraform validation, right? I have validating the Terraform. Now, in order to validate the Terraform, where it has to validate? Inside the Terraform directory. Where is this directory? It is there in the GitHub repository, right? So Terraform directory is Terraform. And how will you validate Terraform? How will you validate Terraform? We have a command called Terraform validate. Terraform validate. That's the command, right? The next stage, Terraform validating is done. So let me copy this entire thing, leaving the last two braces. So I'll copy this entire thing, press enter, paste it. Now, once the Terraform is validated, next, if you want to check the infrastructure, if you want to check infrastructure, let's say I'll keep it as infrastructure check. Infrastructure checks whether infrastructure is getting created or not. So how will you do that? By executing Terraform plan command. Terraform plan command. So I'll go to the Terraform directory. Inside this, I'll give it as a Terraform plan. Terraform plan. Right. It will display the infrastructure that we are going to create. Terraform plan. Now here, instead of directly giving things, what I'll do is I will ask the Jenkins for my approval. Only if I approve, then only it will proceed further. Otherwise, if I deny, it won't proceed further. So that also we can customize. So let me show you how to customize that also. So let's say I'll give it as input message. Okay, I'll give it as a input message. So I'll give the message as, let's say, message colon. It will show it as approve. Okay, once it comes up to this stage, it will show it as approve. Now, If you press OK to proceed, if you press proceed, there will be an option which comes automatically. If you click on proceed, then only it will go and do the next stage execution. If you don't do, it won't happen. So that's what a manual approval we are going to give it here. Manual approval we are going to give. Otherwise, if you want automatically, you can remove this one. But I'll show you this one. This is some advanced concept. So I'm giving it as manual approval here. Right, I have given this one. Now, the next stage that we are going to write is we are going to create the cluster. We have to create the cluster, right? So I'll just copy this entire thing. I'll leave the last two flower brackets. Okay, I'll leave last two flower brackets. Copy this entire thing. And then I'll write one more stage. I'll write one more stage. So what is my stage? Okay, what is my stage? So just give me a second. Yeah, stage. So the stage is, let's say I want to create EKS cluster. I want to create, or let's say destroy also I'll give. I'll do one thing. I'll create or destroy EKS cluster by using an option in Jenkins. When we are configuring Jenkins, we have one option. We have one option which is called as this project is parameterized. We have an option called parameterized. So we can pass manual parameters. If you want to create a cluster, you can select that option. If you want to destroy the cluster, you can select that option. So that option also we can customize. So I'm going to give that customization also. Create or destroy EKS cluster. Create or destroy EKS cluster. So I'll give this one. And then steps. So script I'm giving. So it will go to the Terraform. And whenever you want to approve, so you want to action, right? You want to approve an action. So I'll give it as a action. So it all depends upon the action. It all depends upon the action. So give action -- auto approve. -- auto approve. So it will show us an action. What is that action? Action is create, destroy. We'll do that in Terraform. We'll give that in Jenkins parameterized jobs. We'll see that in some time. And this input message, it's no longer required. So let me delete this entire thing. Let me delete this entire thing. So that's how you can create the pipeline stage view. Okay, that's how you can create the pipeline stage view. Right. So here you can see the environment I have provided, stages. Okay, stages. And the first stage is cloning the code. Okay, cloning the code. And the next stage. Okay, here I have given stages again. So it's not required. So I'll just remove this one. It's not required. Inside stages, we have stages, the stage. So the next stage is Terraform initialization. So I have given it everywhere. By mistakenly, I have copied. So I'll delete everything. So stage. Next thing is Terraform validation. Terraform validation. And once that is done, then it is going, I'll delete here also. Right. Once this is done, the next thing is infrastructure checkup. How will you do that? By executing a Terraform plan command. Once that is done, then we have to create or destroy the EKS cluster that we will configure using a project. This project is parameterized. So if I give approve and then if I click press proceed, then only it will go and create the EKS cluster or delete the EKS cluster. Right. So this is about how to create the pipeline. Okay, this is about how to create the pipeline. So we are done with creating the pipeline. But before clicking on apply and save, as I said earlier, let me go here. You can see under general, there will be an option called this project is parameterized. So select this one, add parameter. So click on add parameter. We need to choose parameter, right? Approve, apply, destroy. These are the two parameters. So we'll go with the choice parameter. So click on choice parameter. So here I have given in the pipeline as an action. If you see in the pipeline, I have given it as a $action. Let me show you that. You can see it here. $action. Let me zoom in a little bit. You can see $action. So that action I'm going to specify here. That action I'm going to specify here. Now, what are my actions? I'll give it as, let's say, apply. That's my first option. Apply, destroy. Apply, destroy. If I select apply, Terraform will go and create an EKS cluster. If I select destroy, automatically whatever EKS cluster that is created, it will delete that EKS cluster. It will delete the EKS cluster. So like these, we can customize the options also in the Jenkins. Right, I have customized it. Once this is done, just click on apply and then click on save it. Once this is done, then we can click on build now so that automatically the pipeline stages will get executed. Let us see that. Let me click on apply and save. Right. You can see the job is successfully created. Now what we will do is let us build the job. Okay, let us build the job. Now you can see an option called build with parameters. So let me click on build with parameters. Now you see it is asking about the action. Okay, it is asking about the action. What I want to do, I want to create the cluster, right? So I'll give it as apply. Once after creating, I want to destroy means then give destroy. So firstly, let us create the cluster. So I'll select apply, then click on build now, build. But before that, do we have any builds? Currently, we don't have any builds. So let me click on build now. Okay, now you can see the stage by stage execution of the job. Okay, stage by stage execution of the job. You can see stage by stage execution. Here you can see it is asking me to approve. Can you see here? It is asking me to approve. Only if I click on proceed, then only it will go to the next stage where it is going to create the cluster. Now, if you want to see the same thing, go to here. So click on #1. If you go to the console output, you will also see the same thing. It will ask our approval. Okay, let the console output comes. If you scroll down to the bottom, now you see it is asking to approve whether I have to proceed or abort. If I click on proceed, then only it will go to the next stage. So click on proceed. Since we have clicked on proceed, now you see it is showing auto approve, and now it is going to create the cluster. So go to Jenkins dashboard. Now you can see this particular stage will take time. So what I'll do is I'll pause this video. And then I'll come back once the cluster is created. Pipeline has got successfully created. You can see it took almost 13 minutes to create the EKS cluster. So you can see the cluster has got created successfully. Now let's go to the EKS console and let's verify whether cluster is available or not. So let me go to the EKS console. So currently you can see I'm there in the North Virginia region, and whatever cluster that we have created, you can see the cluster that is available. Now, if you click on the cluster, you'll get the cluster details also. So you can verify the node groups that we have created. We have given the desired size as 1, right? So whatever the desired capacity that we have given for node groups, so number of node groups will also get created. So currently we have given the desired capacity for node group as 1. So that node group will get created. Once you click on this cluster, you will see the details of all the other things that are related to the cluster. Let me show you those things as well. So you can see the node group also got created, which is the one that we have given. So like this, you can automate the creation of EKS cluster by using Jenkins and Terraform. So I hope you got an idea about how to create an EKS cluster and how to automate that process by using Jenkins and Terraform. So once you build the job, so automatically everything will be done. Now let's say you want to delete the cluster. Okay, you want to delete the cluster. So in order to delete the cluster, what we have to do is, again, just go with build with parameters. Okay, you can see an option called build with parameters. So click on build with parameters. And here, instead of apply, just go with destroy, because I want to delete the cluster. Okay, I want to delete the cluster. Now, before deleting the cluster, whatever activities that you want, let's say you want to deploy an application, you want to create the worker group, worker nodes, those things, you can do whatever things that you want with the EKS cluster. But this video is all about how to automate the creation of EKS cluster by using Jenkins and Terraform. So this video doesn't describe about how we can work with the EKS cluster. Probably in the upcoming videos, I'll be talking about that one as well. But since this video's purpose is just to show you how to create an EKS cluster by integrating Terraform with the Jenkins. So that is what we have seen here. Now, once this is done, just click on build. Okay, so I'm now all the resources, whatever that got created, they will get deleted. So again, this process will also take some time. If you get any kind of error, you have to manually go to the AWS console, especially the EKS service. In the EKS service, you can delete the cluster manually. That is also possible. So that is all about from my end in this video. So I hope you have understood how to work with integration of Jenkins with Terraform so that you can automate the process of creating the EKS cluster. Once after you have successfully completed your deployment of the EKS cluster or the creation of EKS cluster, I would like to listen your views on this video. You can also post these thoughts on the LinkedIn, and you can tag me on LinkedIn as well. This is my LinkedIn URL. And remember that I have posted the GitHub repository URL in the description of this video, where you can find all the Terraform files which I have used. Along with that, the Jenkins pipeline script is also used. Along with that, I have also given the commands which are required to install the Java, Jenkins, Kubernetes, AWS CLI, and Terraform as well. So this is all from my end in this video. Thank you.